Hi everyone. I'm not be able to attend this event, so I made this video to talk about our work. Thanks for coming.
Developers write code. Code editors or IDEs are where the source code are being written. Beside these editors, developers need to deal with many other tools in the developer process. According to the State of Developer Ecosystem 2020 survey conducted by JetBrains, 85% of developers use source code collaboration tools, and nearly 50% developers use issue trackers, CI, or CD tools. Other tools, including static analysis tools and code review tools, are also very popular. These tools that help developers accomplish their work tasks are usually not directly integrated into the source code editors. These tools are executed independently. Some of them are cloud-based, and most of them store their output separate from the source code itself. This imposes overheads because developers need to navigate away from their source code editors. For example, we have tools for running unit tests and generate reports. When we receive an email saying some test fails, we need to go to open the test report. Since the report is separate from the source code, we have to do the manual link from the report to the source code where the failed unit test code is located in order to do further actions. Most external information lacks direct link back to source code. Because of it, context switches and distraction notifications such as emails can reduce our productivity. Noticing the source code itself is the commonality between most of these tools. We have an idea. What if we don't need to use these external tools on interfaces to fetch external information? Instead, the code editor does it for us. There wouldn't be context switches, and notifications can be directly displayed inside the code editors and are actionable. That would be great, right? So in our study, we explore developer preferences and performance with external information in code editors. We focus on representations, and tool designers can consider our findings to improve how they integrate external information with source code editors. There are some design principles to balance the actionability of the integrated information with the risk of that information being overwhelming. First, we think the information should not distract developers, so minimum representation should be preferred. Second, the information should be intuitively expressive, where graphics and colors should be preferred. Because of non-intrusiveness, less information is usually shown to developers. When a developer wants to know more, they should be able to expand the information. Lastly, we also need to make sure one type of information is distinguishable from the others. Now, let's talk about presentation views. There are inline views and isolated views. Inline presentation views are anchored by the source code they adore. The common representations are gutter, highlight, badge, context menu items, and overlays. The overlays are often used to augment the four other representations. Isolated presentation views, on the other hand, are outside the source code area. They are useful when a developer is trying to get an overview or summary of the source code and is not sure which segment of the source code they should be examining. When determining how to integrate an external information source into the source code editor, developers need to balance the actionability of the information with the overwhelmingness of the visual representation. To better understand how developers perceive the utility and the intrusiveness of different visualizations, we prepare concrete external information integrations for a variety of common development tasks into a survey to gather their feedback. The survey was designed to take 10 minutes and distributed online through emails and social media. Each respondent was provided with four common tasks they might perform using external information. For each task, They were given two visual representations created by our prototypes. They were asked to choose their preferences and give rationales. The goal of the survey was to answer two main research questions. Do developers prefer inline or isolated views? For inline views, do developers prefer gutter or badge representations? For the first research question, inline versus isolated, we provided for each task a gutter representation, a badge representation, and an isolated representation. For all scenarios, most respondents prefer to have information show in the code area, which is the inline representation, mostly because of minimalism. Some mentioned that there were too many panels in their code editors already. Some respondents also mentioned that having an optional summary panel could be very useful in addition to the inline representation. For those respondents who prefer separate panels, their primary rationales was because separate panels enable them to only consider additional information when it is needed. A few participants want to be able to combine both inline and independent representations because they like to have options. Inline representations were considerably more popular with the survey developers because they don't like the proliferation of panels around the code editors. Simultaneously, developers found isolated panel better at presenting summary data and have some capabilities inline representation lack. The options to activate an isolated panel from an inline representation could increase the utility of both representations. For the second research question, do developers prefer gutter or badge representations? For each task, we gave them one gutter representation and one badge representation. X for preference and Y. The first finding is for two of the tasks, developers prefer badges over the gutter visualizations. However, for the other two tasks, badges were not preferred. This suggests the characteristics of tasks remain an important factor when choosing between these representations. Participants choosing badges because it has a higher information density. Gutter is more likely cause conflict, and badges are easier to read. On the other hand, gutter fans also have their reasons. When Gutter's tiny space is enough to display the information, they would rather to use Gutter over the badges. Also, the Gutter has a simpler UI, which is less distracting. For the four survey tasks, badges-based visualizations were slightly preferred by the developers over the Gutter-based visualizations. The ability of badges to convey more information seems to be the primary driver of this preference. Correspondingly, space constraints imposed by the gutters can cause the readability issues. Gutter visualizations work for tasks where information can be easily and naturally fit a small footprint. When more information is needed or multiple pieces of information vie for the same inline location, badges are preferred. The survey helped us to understand developers' preferences. To gather further insight into developer performance, we created the External Information Encode Editor Prototype, or EIC prototype. We want to make sure the visualization of external information within the source code editor does not overwhelm the developers or negatively impact their performance. EIC was developed as a plugin for the Atom development environment. We chose Atom Editor because it has the customization flexibility required by our prototype. It is a controlled experiment in which we aim to answer these two primary research questions. Does integrating external information impact task performance? Are there negative consequences to integrating external information? We designed four tasks, selected from our experience. These two tasks are different from the tasks in the survey. The tasks are independent from each other and use the different external information sources. Each task will involve one EIC feature. Tasks are randomized and counterbalanced. For each participant, 2 of the tasks will be completed with EICE and the other 2 will be completed without it. Given the modest number of participants in the experiment, and to gain as much insight as possible in a limited controlled setting, we designed an experiment to focus on the number of actions, NA, and the number of resource switches, NRS, rather than the time required to complete the task. The intuition behind these measures is that the more actions developers need to take to complete the task, the more effort a task may require. Additionally, the more resource switches and the programs involved in completing the task, the more complex the process becomes, increasing the cognitive load to complete the task. Here is an example of action and resource switches counting. Note that we added some supplemental actions to make sure with or without EICE, the final state is the same. In this example, the final state is the active window should be the editor itself and the bug is fixed. The results for the number of resource switches showed that participants using EICE only performed 33% as many resource switches. In fact, 3 out of 4 tasks, T1, T3, and T4, EICE participants were able to use the external information embedded in the code editor alone to complete the task. What happened in T2? It turns out our prototype has a usability issue. As you can see from the screenshot, when we design a prototype, we expect participants to click on the file path, which will navigate to the file. However, participants were more likely to click on the commit, and EICE will open the commit in browser, which caused resource switches. Now let's take a look at number of actions. Participants using EICE for Task 1, Task 3, and Task 4 performed better than with the traditional tools. Across all tasks, participants using EICE performed 71% as many actions. If we take out Task 2, EICE required only 51% as many actions to complete the tasks. So does integrating information impact performance? Yes, in a good way. Participants were able to successfully use external information embedded into their source code editor to both decrease the number of resource switches and number of actions for most of the experimental tasks. Does it have negative consequences? According to our participants, there are concerns about integration becoming distracting. For example, one participant says the inline representation might be too distraction in some cases, or that they would like to have a toggle to easily turn off information sources they were not interested in. We think when integrating information into the source code editor, designers must carefully consider how developers will use and interact with information to ensure they don't actually cause developers to perform more work. As for threads, we injected our design thinking into the survey process, and our dynamic structure made it challenging to directly compare all participants as the follow-up questions were based on their prior responses. We did this to increase the feedback we could get. For the control experiment, participants cannot work on their own projects or tasks. We use our own project and task to allow us to have meaningful control group. For threats to external validity, the limited sample size of the survey and experiments, the single project setting, and the selected task limited the generalizability of the results. To conclude our study, we have 4 findings. The first is external information can be integrated into the code editor without being overwhelming. The second is developers prefer inline representations over isolated representations. Then badges tend to be preferred due to their greater information density, and integrated information should be carefully designed to meet developer needs. Thank you. Now it's Q&A time.